Okay, hi everyone. In today's video, we're going to go ahead and talk about molarity conversions. So remember, molarity is a way to describe the concentration of a solution, which is moles divided by liters. Okay, so moles of solute divided by liters of solvent. And we're going to use this concept to help us convert from one unit to the other, specifically between moles and liters. So in addition to molar mass, remember that's grams per mole, that lets us go from the mass to the number of moles, and Avogadro's number, that's 6.02 times 10 to the 23rd things is equal to 1 mole. Conversions can also be performed using molarity. When using molarity as conversion factor, we're going to use the units of moles per liter. Don't use that capital M in this case, because we need the two different ones so we can have a conversion factor. So where X is the molarity of our solution, so if it's 2 molar, 10 molar, whatever it is, that number is going to take the place of the X. Our conversion factor becomes X moles is equal to 1 liter. So if we have a molarity of 2.5, we would say 2.5 moles is equal to 1 liter. Or if we have a molarity of 0.01 molar, then it would be 0.01 moles is equal to 1 liter. Now, the one thing I want to point out, when we are doing these conversions, molarity is never, ever, ever going to be the given. It's always going to be a conversion factor. So it's never going to go in that first box. It's always going to come somewhere later in the problem. Let's go ahead and work through two different examples today. Okay, so for our first problem, how many moles of sodium hydroxide is needed to create 25 milliliters of a 3 molar sodium hydroxide solution? Now, for these problems, you're going to use a factor label table. Even if you think you can get away with it another way, go ahead, try out the factor label table, because later on this year, we're going to build upon this idea. So I want to make sure you have a strong foundation. So as always, we're going to underline what we're given and circle what we want to find. Now remember, the molarity, that value right here, that is never going to be our given. So I'm going to go ahead, I'm going to kind of bubble it in because it's important, but I'm not going to go ahead and have it be one of my givens. So my given is 25 milliliters, and I want to find the moles. Okay. So one thing I want to remind you, remember, this is going to be the conversion factor, not the given. So instead of writing it as 3 molar, I'm going to say that 3 moles is equal to 1 liter. And I'm going to use that later on in my table. So otherwise, we can go ahead and set things up. Remember, your given always goes in the first spot, so that 25 milliliters is going to go up front. Okay, so if I look, I have milliliters and I have liters. Can't go directly from one to the other, so I have to convert. So I know milli means 1,000. So I have 1,000 milliliters for every 1 liter. Okay, so cross those out on the diagonal. Now, if I have liters on top, I need liters on the bottom. And then I want to get 2 moles. So I'm going to end up with the 3 moles on the top. Okay, so this right here, that is where my molarity is coming into play. And that's how I'm having that conversion factor, one over the other. So I'm going to go ahead and plug these values into my calculator. I'm going to have 25 times 1, which doesn't really make a difference, and then times 3, because we multiply across the top. And then we divide by what's on the bottom. So divide by 1,000, divide by 1. So in order to create 25 milliliters of a 3 molar solution, I am going to need 0.075 moles of sodium hydroxide. Okay, now we always want to stop and think about sig figs. And when it comes to factor label tables, we look at our given to find out how many sig figs, which in this case, we need 2 sig figs, because 25 is 2 sig figs. Well, over here, remember, leading zeros do not count for significant figures. So we have the 7 and the 5, which are significant. So that is the answer that we are looking for. Okay, let's try another problem. Okay, this one's a little bit more complex, but we can do it. If you have 25 grams of table salt, how many milliliters of a 1.2 molar solution can you create? Okay, well, start by underlining your given. We're going to bubble in our molarity, because remember it's important, but it's not our given. And then circle what we want to find, which is milliliters. Okay, so I'm going to rewrite my molarity as 1.2 moles is equal to 1 liter. Now, remember, our given is going to go into the first spot of our table. Okay, so I have grams up top, I need grams on the bottom. And if I look at my conversion factor, it has moles and it has liters. It does not have grams. So I need to ask myself, how do I get from grams to moles? That thing I always want to get to, the middle point. Well, grams and moles, that is molar mass. So let's go ahead and we're going to calculate the molar mass of sodium chloride. So we have 1 sodium. Each sodium has a mass of 22.99. And we have 1 chlorine. Each chlorine has a mass of 35.45. If we add those together, okay, 22.99 plus 35.45, that gives me a molar mass of 58.44 grams per 1 mole. Okay, so that 58.44 is going to go in the bottom. And up on top, we're going to put the 1 mole. Okay, so our grams cancel out. If I have moles on top, I need moles on the bottom. And this is where I'm now going to use my molarity conversion factor. So 1.2 moles up to 1 liter. Now my moles cancel out. If I have liters up top, I need liters on the bottom, because this case is not asking for liters, it is asking for milliliters. Okay, so remember, milli means 1,000 milliliters per 1 liter. Okay, so all my units cancel out except for milliliters, which is my final unit. So we set this up, numbers up on top, we multiply. So 25 times 1 times 1 times 1,000. Okay, and then we're going to divide by the numbers in the denominator on the bottom. So divide by 58.44, divide by 1.2. Okay, so the number that my calculator spits out, 356.49 milliliters. Okay, but we need to use our brains now to think about sig figs. So if I think back to my given, I have 2 sig figs. So I need to round my answer to 2 sig figs as well. So 3 and the 5, they count. I'm going to chop off that 6. Well, 6's round up. So 356 is going to get rounded to 360 milliliters. Okay, always make sure that your answer makes sense when you round your number. It should be about the same thing. So don't tell me 35 or 36. It should get rounded up to 360, because that's about the same thing as 356. So if you have any questions, please let me know. Otherwise, have a great day, everyone, and good luck on molarity conversions.